this okay, here the illustration. Here we have this. Okay, yeah, that one. Okay, so Charle's law states that if the volume expands or increases, so the temperature also increases. So this is directly proportional. So the relation is that so before I give sample problems, I'll just show you a short review. So the relation between pressure between volume and temperature is that in Charle's law is that V1 over T1 equals V2 V2 times T2 over T2. Okay, so this is also represented as V1 times T2 equals V2 times T1. Okay, so this representation states that if the volume is decreases, so this is an example of a piston and a cylinder. So if the gas is compressed, so the volume decreases, as so the temperature also decreases. And then when the cylinder expands, so the volume increase, then the temperature also increases. Okay, so this is the relation for Charle's law. So the temperature here is absolute temperature. That means it should be in Kelvin for metric, or Rankine for English system. But we'll just focus on not too deep, just a basic for this one. So we'll start with problem number 1. So hi to our viewers tonight, good evening. So we'll start with problem number 1 for Charle's law. Okay, so here calculate. I'll just type the problem. So calculate the decrease in temperature. So the problem specify this in Celsius. So calculate the decrease in temperature in Celsius when 2 liters at 21 degrees Celsius is compressed to 1 liter. So to 1 liter So the problem tells us that there's a reduced in volume, so it compresses. So as the volume is decreased, so the temperature also will decrease. Okay, so here Mathcad can let's say the given first. We'll put the given here. So it states that the final temperature, let's say T2, uh, T subscript 2, this is the final temperature, is equals to 21 degrees Celsius. Sorry, this is T1, sorry, this is the initial temperature. So this is 21 degrees Celsius. So in Mathcad, you'll just select here the units we have for temperature. Yeah. So in Mathcad, you can directly convert the units. For example, you want this to be absolute temperature, so we'll just change it to Kelvin. So it will automatically give the value in Kelvin. So without using calculator, so the Mathcad will automatically give you the value in the units, in the desired units. Okay. So now, because in the equation of Charles' law, it should be in absolute value. So you need to convert the Celsius to Kelvin in a metric system, and in English system, Fahrenheit, you'll change to Rankine. Okay, so we have here T1 equals 21 degrees Celsius, or in absolute value, this will be 294.15 degrees Kelvin. And then, in that condition, the initial volume is B1 equals 2 liters. Okay, 2 liters. So Mathcad will automatically recognize the units. So be careful that when you're using this software, you should be you should make sure that the unit is consistent. But even though the unit is not consistent, it's that in the sense that the English and metric is mixing, as long as you have the correct value, so the system will automatically give you the correct value or units, desired units. So now, the final volume, as the problem states that it was compressed. So V2 is 1 liter. So the problem is asking what is the final temperature once a certain gas is compressed to 1 liter, from 2 liters to 1 liter. So what will be the temperature? So we'll just substitute the using this relation, either of these two. So for example, we'll take this one. Okay, so what is asked in the problem is the temperature 2, or T2 equals to V2 times T1 divide V1. So In Mathcad, you will just automatically press equals and then it will give you the answer. So it will be in Kelvin. So 147.075 Kelvin. So the answer clearly tells us that according to Charles' law, once the volume was decreased, so the temperature also decreased, because the temperature and volume is directly proportional at constant pressure. Okay. In Mathcad, if you're using this software, you can, and you're going to present it, you'll just you can add highlighters like this. You can select various colors like this one to give you the final answer. Okay. So that is how it is being calculated in the software. So problem number 2. Welcome to our new joiners, to our viewers. So problem number 2. 600 600 milliliters of air is at 20 degrees Celsius. So what is the volume at 60 degrees Celsius? Okay. So in this problem, it states that, let's say our initial volume is 600 milliliters. So we'll assign this as B1 equals 600 milliliters. Okay. And take note that, for example, I designate this as 600 milliliters and you want this to be in liters, you'll just type the unit here and the value will automatically change. ml equals, yeah, it will automatically change to 0.6 if you change this to liters, like that. And if you want this to be in cubic foot, let's say, I'll just show you the features of this software. In cubic foot, it will automatically give you that value in cubic foot. And if you want this to be in cubic meter, it will automatically give you the value as 0.1. And then you can designate the decimal places you want. Okay, so let's proceed. So this volume at this temperature T1 20 degrees Celsius. Okay, and then the final volume or V2 is 60 degrees Celsius. Okay, so what is being asked is the sorry, this is temperature. This temperature 2. What is being asked is the volume at 60 degrees Celsius. So using this relation, okay, enter. I'll assign it here. Okay, using this relation, I think we'll move it here so that the watermarks will. Okay, using this relation, we can calculate the value of V2. So V2 is equals to volume 1 times T2 divide T1 equals, so the final temperature will be 682. So that means let's say we'll put milliliters, okay, to make it consistent. So this is 681.869 milliliters. All we can reduce the decimal places here. Let's say 1 decimal place, yeah, 681.9 milliliters. So you can see that there's an increase in volume as the temperature increased. So this is the Charles law. Okay. So for we'll go to problem number 3. And guys, can please follow and share our channel or our stream for an updated contents, because I'm going to stream also other areas like mathematics and general sciences. So we'll go to problem number 3. Problem number 3. So a gas occupies 900 milliliters at a temperature of 27 degrees Celsius. So what is the volume at 132 degrees Celsius? Okay, so using the same relation as this one, because this is still Charles' law, we can use this equation. So in Mathcad, you can, for example, you have already an initial let's say we'll assign first the given. So let's say this is V1. Say this is V1. As 900 milliliters. And temperature is 27 degrees Celsius. Okay, so at this temperature T2 132 degrees Celsius, what will be the volume in this temperature? Okay, so in Mathcad, for example, you are using this for your presentation or as a way of taking notes for review. If you're using Mathcad, so you can just copy the equation in the previous number. You can copy this and you can paste it here, and it will give you the answer. Wait, math formatting, and it will give you the answer based on that, on the condition at number 3. So this is now for number 3. So that is how easy is Mathcad for computation or calculation. So it will automatically give you the answer. So take note that the temperature here increase, so we expect that the volume also increase. So as shown in here. So let's say we'll put this highlight here. Okay. And then we'll go to problem number 4. So before proceeding to problem number 4, we'll review first the relation. So this is the relation in Charles' law. For example, this is a cylinder. So for example, if the piston compressed air, or for example, this is a cylinder and this is an air fuel mixture. So if the cylinder is the piston compressed the air inside the cylinder, as the volume decrease, so the temperature also, I mean, if the volume decrease, so the temperature decreases. And if the piston expands or the volume expands here, as the piston moves up, so the temperature also will increase. Because for example, I'll give you an example. If this is an actual engine, for example, if this is an actual engine cylinder, and this is, for example, diesel cycle, if the mixture of diesel and the compressed air is compressed by the cylinder, then it will expand. So as that expands, so there's an increase in temperature, and then explosion occur, and then the piston will move. Repeated action. Okay, so that is the principle. So it started in the basic relation of Charles' law. Okay, so it is important that you'll understand the basics so that you will easily understand the principles of the higher sciences or engineering. Okay, so we'll proceed with the problem number 4. So what change in volume results? Okay, this is quite different, so this is good. So what let's say 4. What change in volume? What change in volume? In this problem, there's a quite a little twist. Okay, so what change in volume results if 60 milliliters of gas is cooled from 33 degrees Celsius to 5 degrees Celsius. Okay. So the question here is not the final volume. So your final answer here will be the change, the difference between the initial, the final wait. So this is called. So this is the difference between the initial volume and the final volume. That will be your final answer. So first, you'll to determine the answer is that you'll using the equation, the relation in Charles' law. This equation here. You'll copy this one and paste here, and then the initial volume subscript 1 equals 60 milliliters and the initial temperature T1 equals 33 degrees Celsius. Okay. And then the final temperature is being cold, so the temperature reduced. Okay, T2 equals 5 degrees Celsius. Okay, so using this relation in Charles' law, we can determine the V2 or the final volume in this condition. So V1 times T2 divide T1 equals, so we'll change this to milliliters. We'll just type ml here, and then the value will automatically change to milliliters. So here, since the temperature decreased and the problem states that it was cold, so the volume also reduced, so 54. But what is asked in the problem is the change. So that means the difference between the final volume and the initial volume. Since the initial volume is greater than the final volume, so we can, let's say, we'll assign here as V volume change subscript C, or volume change, is equals to V1 minus V subscript 2, and it will give you the difference equals, so we'll change this to milliliters to make it consistent. It is important that our units is consistent so that we won't get confused. So the difference here is 5.488. Also, I'll change this to 1 decimal place. It will give you 5.5 ml. So that means the difference in volume is 5.5. Okay, so that is the change in volume. So you should be careful that if you have this subject in your, for example, if you have subject in physics and then you encounter this problem, you should be careful that you will subtract the volume, the initial volume and the final volume, and the conditions that will determine the change in volume. Okay, so the last problem for tonight, problem number 5. Text box. And guys, please don't forget to subscribe or follow for more content. So I'll be arranging different topics every night, or as much as possible every night. I'll try that. And then different topics in various sciences, general science and mathematics, using this software. This is freeware. Actually, this software is free. It's for free, but it has also advanced features in its premium version, which is you're going to pay. But for the basic one, the free version is enough. For example, if you are a student in high school and or college, you can use this as for your studies. This is for free, and the feature is enough for studies. Advanced feature is for higher calculation, like for engineering. But sad to say, there's no mobile application for Mathcad. This is only for laptop, but it doesn't require higher specs. Just a basic one, basic laptop, it can handle this application. Okay, so we'll proceed. But for your tutorials, review, consumption, you can just watch my videos. I will post the entire videos in YouTube for your reference later on if you want to review. Okay, this is for your tutorials. Okay, so we'll proceed to problem number 5. So given 300 milliliters of a gas at 17 degrees Celsius, what is the volume at 10 degrees Celsius? What is the volume at 10 degrees Celsius? Okay, so for any problem in either math or science, so the first approach is that you will first understand the problem, right? You cannot answer the problem if you won't understand it. So in the problem alone, you can based on the principle of Charles' law, that if the volume increased, so the temperature also increased, and if the volume decreased, so the temperature also will decrease. So in this problem, you can see that the temperature decreases, so we'll expect that the volume will decrease. Okay, so given in the problem is volume 1 equals 300 milliliters, and the temperature is T1. I will move it a little. T1 is 17. Okay, so what is the volume at 10 degrees Celsius? I will move it a little here, a little bit here. Okay, so T2 is equals to 10 degrees Celsius. Okay, so given this relation here, we'll copy this first. This is the basic relation of gases between the volume of gas and temperature in Charles' law. Okay, at constant pressure. Okay, so we can just copy this equation because we're looking for volume 2. Okay, so we can just copy this equation, okay, and paste it here, and then it will give you automatically the answer for this equation, for these conditions. Okay, so you'll notice that it is taken from here, which is the answer is 54 here for this problem, and if you paste it here, given this condition, it will give you the answer based on this conditions. Okay, so that is how easy to calculate using Mathcad. So will format this to this one decimal place. Okay. So the final answer is 292.8 milliliters. We'll highlight this to, let's say, orange. Okay. So you can see that the volume decreased since the temperature decreased. Okay. So that's it for tonight. Thank you for watching and joining me in my live stream. So hope to see you again in my next stream on different topics again. Thank you. If you have questions, you can simply message uh, my channel. Yeah, you can directly message me if you have any question. Thank you and good night. So if you have any questions, you can just message me directly. Thank you. Bye. So I'll end now my live stream. Thank you.